Hello guys, welcome to my channel. You're welcome to Master Data's online academy. The only online academy where you can learn all the tips as to how you can gain mastery in any engineering and science problems. Of course not, in this channel we unveil secrets. So in this channel we always unveil mysteries. Remember, here on this channel we teach principles that works. So as far as you are ready to learn again now, I'll be holding you by the hand and showing you again exactly how to use advanced method to approach simultaneous equations with three unknown, like you can see on the board. In our previous lesson, I taught you how to solve simultaneous equation with two unknowns. And then I did mention that you can use the elimination method, which we used, substitution method, which we used, and then second elimination method, and then we were not able to use the graphical method. In the same vein, I did mention as well that to solve simultaneous equation with two unknowns, you must be given two equations. The same way, to solve simultaneous equations with three unknowns, you must as well be given three equations that will enable you find the three unknowns. So in this video, I will not be showing you the conventional method. I will be teaching you the advanced method of solving simultaneous equation with three unknowns. Of course, you can use the elimination method to solve this. You can use substitution method to solve this, and as well, you can use graphical method to solve it. But in this lesson, I will be showing you how to use the matrix method, number one, which is known as determinant method as well. I will also be showing you how to use the Gaussian elimination method. And then I will show you how to use inverse matrix method. I hope you are mind blown already. So guys, don't forget to like this video, share this video, and make your positive comment at the comment section. Without further ado, let's dive into this business. Lest I forget, guys, don't forget our principle. You must not skip any part of this video for your own advantage. This is because every bit of this video is encrypted with principles that work. Remember, when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundary. So guys, let's dive into the first method. On the board, we have a problem. Don't forget simultaneous equation with three of them. And then we are asked to solve the set of linear equation. First equation is given as this. Second equation is given as this. Third equation is given as this, right? Now, to some persons, you may be given this in terms of x, y, and then z. They are all the same. So changing of alphabetical letters shouldn't scare you. It doesn't change the pattern of solving. So whether you are given in different letters or you are given in the same letter to different subscripts, like we have this now, x1, x2, x3. In this case now we can liken x1 to be x, and then y to be x2, and then z to be x3. So these are the three unknowns. But as we have it here, we have x1, x2, x3. So in another question, you may have y, x, y, z, or any other three variables. All right? So if this is clear, what do we know? The first method here to use is to what? Apply the matrix or determinant method. So let's put down our solution. Solution. In order to be able to use the matrix method, the first thing that you need to do is to state the future ahead of time. Let's define the promised land so that we know how to navigate ourselves, the path to travel through, so we can reach the promised land with ease. Are you following me? Okay, now, if this is clear, the first thing you gotta do is to find x1 is that x1 is equal to determinant of x1 all over the overall determinant. In the same way, to find x2, x2 will also be determinant of x2 all over what? The overall determinant. Then, to find x3, this will equally give us the determinant of x3 all over determinants. So there are four determinants to obtain here. The first is the one with respect to the coefficient of the unknown. Then the other is to find the one with respect to x, the one with respect to x2, the one with respect to x3. The same thing, if this is x, y, and z, like we have it on the board, then this will be x equals to change in x over the change, which is your determinant, which represents the determinant. Okay? Then then x2, which will have a y as we have it here, equal to what? Change in y all over y, the change, right, which is equal to change in y over the change, which stands for the determinant. And then if this is z, this will be what? Z equals to what? Change in z all over change, which stands as determinant. So where this guy equals determinant. Okay, if this is clear, so let's quickly do the needful. So the first thing we want to do to this set of equations is to convert them to their equivalent matrix form. Alright, so is to convert this set of equations to its equivalent matrix form. Writing the set of equations in matrix form. So to be able to do this, guys, the first thing we want to do is that, remember in matrix, these elements in matrix form are arranged in rows and as well in columns. Are you there? In rows and then in columns. So now, the first column will be the coefficients of x1. The second column will be the coefficients of x2. And then the third column will be the coefficient of x3. The fourth column will be x1, x2, x3, or x, y, z. Are you there? So all we need to do now in matrix form, let's get the coefficient of x. Here, the coefficient of x1 here is 1, that of it here is 2, and that of it here is 3. So we have 1, 2, 3. Remember that this is a symbol for matrix. Then when we come to the middle, which is x2, the coefficient here is 2, that here is minus 1, and that here is 2. So we have this as 2, negative 1, 2. Then when we move down to the coefficient of x3, we have negative 3, negative 1, 1, right? So we have negative 3, negative 1, 1. All multiplied by. Now, this becomes x1, x2, x3. All equal to. Now, at the end of the equal to, these are the coefficients that you have on the constant. So, all that you have here will serve that matrix. So, this becomes 3, 11, and then minus 5. So, this is this set of equations in its matrix form. This is the first thing we do. This is the first thing. So, now the next thing we gotta do here is to ensure that we are able to find the determinant of this guy. Are we there? In order to solve this problem, we need to find the determinant of this guy. It's as simple as that. So to be able to find this determinant, we will take out this coefficient of x, which is x1, x2, x3, or x, y, z, depending on the variables that you have. Alright? So that we'll ask you to find delta. So show that we are finding determinant, this curve would have changed to a straight line, like you're going to see now. So this guy becomes a straight line of 1, 2, negative 3, 2, negative 1, negative 1, 3, 2, 1. Alright, so having gotten to this level, because we are using the determinant method, we can either use Crammer's rule or we use Sarah's rule. But in this case, I'm going to show you how to use the Crammer's rule because that is the one that is generally invoked. Okay? So, but in another module, I will teach you exactly how to use Sarah's rule here to obtain the determinant of 3 by 3 matrix. Are you there? Alright. So, in order to use Crammer's rule here, all we just need to do is to introduce plus, minus, plus, this is the method, plus, minus, plus. Then we have to reduce this 3 by 3 matrix first to 2 by 2 matrix. Okay, so we pick our determinant. This is equal to, so to be able to reduce this 3 by 3 matrix to 2 by 2 matrix, this is what you do. You get the elements in the first row and then multiply by the sub element. Look at what will happen here. So I'll pick the first element here in the first row. This is the first row, second row, and then third row. So that element is 1. Then open 2 by 2 matrix. Are you there? Then you pick the next element. This is minus 2. Alright? And then you open 2 by 2 matrix. Then the last is plus minus, will give us minus 3. Then again you open 2 by 2 matrix. So look at how we are going to fill in this gap now, or how we are going to fill in this table. In order to put in 2 matrix elements here, look at what will happen here. If I am at this level, okay, I will block the horizontal members or horizontal elements that are connected to this point, and then all the vertical elements that are connected to this point. Remember that 1 is our emphasis, right? So as we are at this point 1, if we cancel like this and cancel like this, or draw a line like this way, and then draw the horizontal line this way, the elements that are left untouched with the line we draw become the elements that you put here. So in that case now, this will be the elements that we have here. Minus 1, then 2, 1. These are the elements that will not be interrupted when you draw a horizontal line here and a vertical line connected to this number 1 here. Right? So if we are done with this, we now move to this middle term. So while we are at this level, we also draw down a vertical line to cover these elements and then draw a horizontal line to cover all these elements. So the element that will be left untouched, if you draw a line here this way now, will be 2, 3, then minus 1, 1. Are you there? Then finally, if you are at this level, if you also cancel all the elements in the vertical direction connected to this number, and then the same way horizontal, we are going to have the first 2 elements here and the other elements here, which gives us 2, 3, and then negative 1 and positive 2. This is it. Having reduced this by 2 by 2 matrix, according to Crammer's, the next thing you're going to do again is to introduce plus or minus to the respective columns that we have here. So the first column takes plus, second column takes minus, second column plus, minus, plus, minus. Don't always forget to introduce this. This is Crammer's, okay? I think I will help you with that. Crammer. Okay, Crammer's rule. So that's the rule that we are adopting here. This is what we are using. So in using Crammer's rule, we must pay attention to all of this sign. Alright? So if this is clear, the next thing we're going to do here now is to obtain the determinant. And how do we progress from here? Because we have succeeded in reducing this matrix to 2 by 2 matrix, we'll now do what we call diagonal multiplication. Diagonal multiplication. So this element got to multiply this, and then this element multiply this. So diagonal multiplication means minus 1 will multiply this. This will have given us negative 1 into minus 1 times positive 1 will give us negative 1. Now, minus, remember that there is negative here to introduce. So minus times minus is already plus 1 here. So 1 times 2 will give us plus 2. We are done with that. Then we move down to this negative 2, open a bracket. 2 multiplied by 1, diagonal multiplication. Hope you get that. 2, and then negative will also give us this as positive 1. Plus 1 multiplied by 3 will give us positive 3. Then we have this as plus 3, then minus 3 into. Again, we will do diagonal multiplication here. 2 multiplied by 2, that will give us 4. And then minus will equally give us plus 1 there. And then plus 1 times 3 will give us plus 3. As simple as this, guys. So having done this will have given us now 1 into minus 1 plus 2 will give us plus 1. And then minus 2 into 2 plus 3 will give us 5. And then minus 3 into 4 plus 3, that will give us 7. Now we need to clear off the brackets. And then if we do that, 1 multiplied by 1 gives us 1. 2 multiplied by 5 gives us 8. And then this multiplied by this gives us negative 21. 3 multiplied by 7. And then if we sum up all of these guys that we have here, this will have given us negative 30. This is the determinant of this particular matrix. Alright? So this is the first thing. We just obtain the denominator of the respective of known. So if I want to find x, I will decide that I want to find x. Then there is something I will do to the coefficient of x. I hope you are getting massive values already. Remember, in this channel, we are not interested in solving thousands of problems, but our interest is to teach you the principle. By solving one problem for you, with you, you should be able to solve as many problems at your disposal using this same approach. Are you there? So please and please avoid distraction and hence follow me up step by step. Now let's take it. Now we'll say to find x1. So because I want to find x1, knowing fully well that this is my formula, and I've only obtained the denominator, I will now need to find the numerator first. So to find the numerator, if I call this delta x1, alright, so this delta x1 is also the determinant with respect to x1. Determinant with respect to x1 or with x, assuming you are given x, y, and z. Are you there? So with respect to the first unknown. So in order for us to be able to find this determinant, what we are going to do now is to exclude all the coefficients of x and then put in the values that we have at the right hand side. Remember that this is our matrix as we have it here. So because I want to find x now, or x1, I will terminate or remove all the elements in the first column and then replace it by the elements here at the right hand side of the equation. Is that clear? The same thing you do if you want to find x2, you terminate the elements or that are in that column and replace it with it. The same way if you want to find x3, I will terminate the elements and then replace it with these elements. It's as simple as that. Okay? So all we need to do now, we are going to do the same thing we have done here, but different coefficients. So in place of x1, I will put in these values. 3, 11, minus 5, determinant. Then I will repeat every other coefficient that I have there. Alright? Minus 3, minus 1, positive 1. So you see, the difference between this and this now is that we have replaced the coefficient of x1 by the constants that were given at the right hand side of the given equation, which is 3, 11, and minus 5. So they now replaced the coefficient of x1. Hope this is clear enough. All we need to do is to also find the determinant of x1. Are you there? So the same thing we did before is what we are going to do now. All we need to do now is to first reduce this guy to 2 by 2 matrix. Then the first column goes with positive, the second goes with negative, the third goes with positive, using Crammer's rule. Are you there? Now, in order to solve this problem effectively, we now have delta this guy, x1. Alright, now we pick the first element here like we did before. All the elements in the first row, we will take them up. So the first element there is 3, then you open 2 by 2 matrix. The second element there is negative 2, open 2 by 2 matrix. Then the third element there is plus and minus 3, will also give us negative 3, open 2 by 2 matrix. Alright, this is it. So what element should be here? While I am at 3, I'll cancel this way, we have negative 1, 2, 1. If I am at the middle here, if I cancel like this, we have 11, minus 5, and then minus 1, 1. And then finally, if I am at the last column, under 3, cancel like this, then cancel like this, I will have 11 minus 5, minus 1, 2. This is it. Having gotten to this level, reduce this 3 by 3 to 2 by 2 matrix, we still need to introduce plus or minus. Alright? So the first column, plus, minus, plus, minus, plus, minus. Having done this, then we now need to do what we call diagonal multiplication. Guys, are you mind blown already? Are you beginning to get massive values already from this channel? Remember, I promised to hold you by the hand and show you exactly how these things are done with ease. Let's go. Alright, so we have delta x1 is equal to 3 into negative 1 multiplied by 1 will give us negative 1. Remember that it's negative here. Negative times negative give us positive 1 there. Then 1 multiplied by 2 gives us positive 2. Then minus 2 into Again, positive 11 multiplied by positive 1 will give us 11. Alright? Then minus minus will have given us here plus 1. Then plus 1 multiplied by negative 5, we will have this as negative 5. Minus 3 into 11 multiplied by 2 will give us positive 22. And then negative negative here equally will give us positive 1. Then positive 1 times negative 5 will give us negative 5. It's as simple as this, guys. All we need to do here now is to have this as 3 into minus 2. Minus 1 plus 2 will give us positive 1. And then minus 2 into 11 minus 5 will give us 6. Then minus 3 into 22 minus 5 would have given us 17. It's as simple as this, guys. Having gotten to this level, all we need to do is if we multiply 3 by 1, we have 3 just to clear up the brackets. And then if we multiply this guy, we have 12. And then if we multiply 17 by 3, we have 51. You can confirm this, alright? We have negative 51. Simple as this. So now, if you, this is minus 12 minus 51 would have given us minus 63. So you can decide to put down these 3, and then minus 12 minus this will give us minus 63. Automatically this will give us minus 60. So 3 minus 63 will give us minus 60. Therefore, x1, which is changed in data x1 to this guy, and then this is equal to minus 60 divided by, the answer we have for this other guy is minus 3 there, sorry, minus 30. Is minus 30, so put in minus 30 there. Minus divided by minus is plus, and 60 divided by 30 is 2. Is it hard? Not hard at all. Then x1 is equal to 2. We have been able to obtain the value for x1. The same thing we have done to obtain the value of x1 is what we are equally going to do to obtain the value for x2, and we will do the same thing to obtain the value for x3. Guys, if you are yet to subscribe to this channel, at this point, do consider subscribing to our channel and then turn on the post notification there so that you won't miss out of our mind-blowing content. Guys, let's dive into obtaining x2. Alright guys, so to find x2, we need to find delta 2. Look at the formula here. As we stated, remember I told you, define the future from the beginning. Let's define the beauty of the promised land while we are at Egypt, right? So this is it. We have obtained this as 30, but we need to obtain this so that we can find x2. So we have delta x2 will be equal to a matrix 3 by 3. Or what are we going to do here? Because I have decided to find x2, which also represents y in xyz equation. Therefore, I will have to trace the coefficient of x2 and replace it with the value I have at the right hand side of this equation. That means I have to keep the coefficient of x1 and as well keep the coefficient of x3, but I will replace that of x2. Get it? Alright. So we have 1, 2, 3, which are the coefficient of x1. Then everything here will be replaced by 3, 11, and then negative 5. And then we have coefficient of 3, x3 remain intact. Again, because we are using Crammer's rule as usual, we will quickly introduce plus, minus, plus, and then reduce this expression to 2 by 2 matrix. Is that clear? Then we have delta x2 is equal to, so the first element here is 1. Then we will open 2 by 2 matrix. Then the next element here is minus 3 from the first row. Then the last is minus 3 again, which is the last element in the first row. So guys, we have been able to achieve this. Next is to fill in this 2 by 2 matrix. And to have this done, if I am at 1, I'll block all the horizontal elements connected to this, and then all the vertical elements here, and all the horizontal elements. I will be left with 11 minus 5 minus 1, 1. The same way, if I am at this point, which this is where we are now. If I cancel all the vertical elements here and cancel all the horizontal elements, I won't be left with 2, 3, minus 1, 1. And then by the time I move down to the last element there on the first row, and then the third column, if I cancel like this, I will have 2, 3, 11 minus 5. It's as simple as this, guys. So if this is clear enough, all we need to do again is to introduce plus or minus, plus or minus, plus or minus. This is a condition that you must not joke with anytime you are using determinant method by Crammer's rule. Are you there? So in order to have this achieved, guys, this become 1 into, remember we are doing what we call diagonal multiplication. 11 multiplied by 1 will give us 11. Now, this is negative 1 multiplied by negative 1 will give us positive 1 here. So, plus 1 times negative 5 will give us minus 5. Then minus 3 into 2 multiplied by 1 is 2. And then minus would have taken this guy to positive. Okay, there? So, plus 1 multiplied by this will give us positive 3. Are you here? Then, this is negative 3 into this guy multiplied by this guy would have given us negative 10. Don't forget that positive 2 multiplied by negative 5. And then negative 11 multiplied by 3. That will give us negative 33. So guys, this is just as simple as this. Very simple. All we just need to do now is to what? Simplify this. 5 from 11 gives us 6. And then 3 into this guy would have given us what? 5. 2 plus 3. And then minus 3 into minus 43. Hope you can get this clear. That's right. Then, if we open the bracket, we have this as 6 multiplied by 1, 26. Then this will give us negative 15. And then this will give us minus multiplied by minus. Will give us positive here. You catch it? Then 3 times 3, 9. 3 times 4, that gives us 12. So that gives us 129. Remember that 6 and 129, they are both positive. All I need to do now is that I can actually add them together so that this would have given us 135 minus 15. As simple as this. So if we remove 15 from 135, we are going to have this as 120. So we have this as 120. This is delta x2. And then remember that to find delta x2, there is a formula here that we have defined. So therefore, x2 is equal to delta x2 over delta. And don't forget that the delta here is negative 30. That was the first determinant that we obtained for the Varrock coefficients of the unknown, right? So with that, x2 is equal to minus, that's positive 120 divided by 30, that's negative 30. Now, plus divided by minus is minus, and then 120 divided by 30, that's 4. Then we have this as negative 4. This is the answer to x2. So finally, let's quickly find x3. To find x3, the same way. How do we find x3? In order to find x3 here, guys, all we just need to do again is to come back to our first step where we converted the set of equations to matrix. And then keep the coefficient of x1 intact, keep the coefficient of x2 intact, and then replace the coefficient of x3 that we are about to find by what we had at the right hand side of this expression. Is mathematics hard? Not at all. Only principle helps you gain mastery. And that's why you are here, so you can gain mastery in this topic. Let's go. Then we will have delta x3. We input 3 by 3 matrix, so we keep the coefficient of x1, 1, 2, 3. Then that of x2, 2, 1, 2. And then that of x3 will be replaced by 3, 11, negative 5. Remember that we are about to find the determinant with respect to x3. Are you there? Which is the same thing as z. Peradventure, you are given x, y, z. Are you there? Now, if this is clear, Using Crammer's rule, we introduce plus, minus, plus. Again, we need to reduce this 3 by 3 matrix to 2 by 2 matrix. How do we get this done? We pick all the elements in the first row and then reduce this. So we have delta x3 is equal to, the first element in the first row is 1. Then create 2 by 2 matrix. The second element in the first row is -2. Then create 2 by 2 matrix. Then the last element in the first row is +3. Then we create 2 by 2 matrix. It's as simple as this. Having done this, then the next is to come back to this 3 by 3 equation again. And then if I block all the elements connected to these elements here, vertically and horizontally, I will be left with -1, 2, 11, -5. And then again, if I am at this level, second element in the first row, by the time I block this element vertically and horizontally, I will be left with 2, 3, then 11, and then -5. Then finally, if I am at this last end, I will have this cancel will have 2, 3, -1, +2. It's as simple as this, guys. So the next thing we want to do is to quickly introduce plus or minus to these columns. Then we have plus, minus, plus, minus, plus, minus. All we need to do now is to quickly do what we call diagonal multiplication. Are you there? So in applying this theory, we have 1 into this multiplied by this. Remember, -1 multiplied by -5 will give us +5. And then -11 multiplied by this guy will give us -22. It's as simple as that. Then we have -2 into 2 multiplied by -5 will give us -10. And then -11 multiplied by 3 will give us -33. Then +3 into 2 multiplied by 2 will give us +4. And then -1 will have given us +1 here. And then +1 multiplied by 3, we have +3. It's as simple as this. All we need to do now is to clear up the bracket. Then we have 1 into, if we remove 22 from 5, we'll have -17. -17. -2 into, if we -10 minus 33 will give us -44. We have -43. And then plus 3 into 7. That's 3 plus 4. All we need to do is to clear up the brackets, and then we have this as -17 minus. Now remember, minus times minus is plus. And then 2 multiplied by this guy will give us 86. It's as simple as this. Simple as this. Then plus 3 multiplied by this is 21. So all we just need to do is to have -17. If we add this guy to this guy, which is 86 plus 21, we will have this as plus 107. Simple as this. So if we remove -17 from 107, or 107 minus 17, we will have this as 90. Then this is 90. +90 for that matter. That's it, guys. What's next? Remember, we have been able to get the parameters that will help us find x3. Therefore, x3 is equal to delta x3 all over delta. Knowing fully well that delta is -30. Then this will give us 90 divided by -30. And we have this as -3. Hence, x1 is equal to -2. x2 is equal to, like we have here, x2 is -4. And x3 is -3. These are the values for the unknowns that we have in this set of equations. So to be able to checkmate whether you are actually correct with these values you just obtained, all you just need to do is to pick one of these equations here. By the time you substitute the value of x1 here, value of x2 here, value of x3 here, and at the end you simplify, you should be able to have 3. So if you have 3, you are correct. But if you do not have 3, you are very, very wrong. Why? For every equation to be valid, the right hand side must be equal to the left hand side. This is the theory of equation. So guys, as I promised, I have shown you exactly how to apply this matrix method to solve 3 unknown set of equations. Very quickly, without wasting much of our time, we will dive into the inverse matrix method. Again, remain tuned, stay tuned, because you will be mind blown again. Thank you for watching. See you guys in that wonderful section where I will be holding you by hand and showing you again how to solve 3 unknown set of simultaneous equations using advanced approach. Alright guys, welcome back again to another section with me. Welcome to Master Builder's Online Academy. Stay tuned as I hold you again by the hand and walk you through the processes involved in solving set of linear equations. In fact, 3 unknown linear equations using inverse matrix method. Now let's dive into this business. On the board again, we are asked to solve a set of linear equations using inverse method, which is method 2. We have used method 1 already. If you have not watched that video, quickly check it out. Alright? Then this is 3 by 3 set of equations to be solved using inverse matrix method. Like I told you before, we are using advanced approach, not the conventional method that we know, elimination and then substitution added to that graphical approach, right? So now let's move ahead. So the first thing we want to do again is to define the future from the beginning. What are those things that need to be done to be able to solve set of linear equations using inverse method? What are those things? It's always easier for you to solve problems if you can see the future from the beginning. I want to show you this again now. So for us to be able to use this method effectively, we will need to state the future ahead of time. Remember, we are looking for the unknown. So to be able to find x1, x2, x3, or x, y, z, this is the equation. X is equal to A inverse multiplied by B. This is equation 1. This is the first equation that will enable us find the unknowns using the inverse method. But this A prime here is the inverse of matrix A. Inverse of matrix A. But by standard, this is usually given as AX is equal to B. Like we'll have it as we progress. Okay? AX is equal to B, meaning this A represents the coefficient of the unknown, YX represents the unknown, and then B represents the constant that you normally have at the right hand side of the equation, like we have here 3, 11, and then negative 5. Okay? So again, to find this A prime, we'll be able to find this inverse of matrix A by having 1 over A modulus multiplied by what? Adjoint of A. Or you can call it transpose. Okay? Or 1 over this guy multiplied by C transpose. This we will call equation 2. And then, if you call this equation 2, this is what we need to be able to find this inverse. That means we cannot use equation 1 unless we have used equation 2. And how do we find this equation 2? How do we obtain this inverse? We need to find determinant of A, adjoint of A, which is the same thing as transpose of the cofactor. And then, before we can get that. So how do we begin this journey? The first thing you want to do is to represent these sets of equations in its equivalent matrix form. And then we have done this first in the first method that we did, right? Using the matrix or determinant method. So I did clean it again. That's what we already have it. So we have already converted these sets of equations to its equivalent matrix form, as you can see. So what we just need to do now is to extract these parameters based on this equation or relate this matrix to what we have here. So how do we relate it? What we have now, in order to relate this, I just mentioned that A, X is equal to B based on this arrangement. So this big bracket that contains integers represents your A. This column here represents X, and this other column represents B. So I can boldly say here A is equal to 1, 2, 3, 2, -1, 2, then -3, 1, 1. Then B is equal to 3, 11, -5, and then X is equal to X1, X2, and then X3. Alright, so this is what we have. By breaking down this expression here, or this matrix, we are able to obtain that this coefficient here represents A, this value at the right hand side of this equation represents B, and then the coefficient of this guy here represents X. Remember, this case, X also serves for X, Y, Z, assuming you were given X, Y, Z in these equations. Alright? So here can be X, Y, Z. But here we have X1, X2, X3. Having done that, the first thing we want to do is to come to equation 2. What is the first element there? Inverse of determinant. So we need to first of all find the determinant of A. So to find the determinant of A, this is no longer a problem to us, right? So we have A is equal to 1, 2, 3, 2, -2, then 3, -1. This is it. I get it? This is it. So this is now the determinant of A. So we are trying to find the first element here, right? So how do we find this? You can use Taylor's rule. You can as well use Crammer's rule. But because of we want to maintain uniformity, we will use again the Crammer's rule that we used using the first method. Okay? So in order to use Crammer's rule, what you do is introduce plus, minus, plus. Can I save your time? Paraventure, this is an exam question, and then you are now asked to use the 3 methods or the 2 methods as the case may be. Guys, you don't need to stress yourself. Already we have calculated for this determinant. Remember, the data that we calculated for in the first method we used, which was -30, is the same thing we are going to have here, even though we use the same method. I don't know if you're following. You're getting it right? So the same thing we obtain here is what we are going to obtain there. The same thing we obtain there is what we are going to obtain here. So if you don't have that time, you can boldly say that whatever you have here is already equal to -30. Do you catch it? That's it. I think that would be the best way you have catch it. So the first thing you do, step number 1, is to find the what? The determinant of A, and we have just obtained it. I hope this is clear. But if it is not clear, just go back to the first video so that you watch how we obtain this 30. If it is clear, let's go. I know you're my guy. You understand it very, very much. Okay. Now, the next thing we're gonna do here, since we have obtained this, is to obtain this algebra, which is the transpose. See, transpose. So we begin by cofactor. C is given as A. So to find the adjoint of A, which is the same thing as transpose, C transpose, this is how you find this. So we want to find new elements that would replace the existing or the original coefficient of the unknowns. A11 represents this one, this guy, and this guy. But in this case now, we want to find new values that will replace the initial elements that we have as the coefficients of x1, x2, and x3. They are. Alright, so guys, let's move. So what do we do? Or don't pronounce this as A11, A12, A13, A14 is out of place. Or A21, A32, no. It's A11, A12, A13. Which shows that this is the first element in row 1, column 1. This is what it means. A, arrow, C. So this serves as row, then this serves as column. Okay? So if I am here, this is the first row. Remember that your rows are like these rows. And then this is your first column. So this is C1, C2, C3. Arrow 1, arrow 2, then arrow 3. So if I am here, this is 1, 1. If I am here, this is 1, 2. If I am here, this is 1, 3. As you can see. The same thing, if I am here, this is 2, 1, 2, 2, connected, then 2, 3. Then if I am here, this is 3. Either row comes first. 3, 1, 3, 2, then 3, 3. That's how it is called. So it's not 33, it's A3, 3, which represents row 3, column 3. Hope you have learned that already. Okay, guys. Now, in order to find the new values that will possibly replace the existing values, we are going to find the determinant in 2x2 formats. Are you there? So if I want to find A11, let's start beginning with A11. A11 is equal to, open a determinant of 2x2. Then A12 is equal to, open a determinant of 2x2. Then A13 is equal to, open a determinant of 2x2. For the first column. Now for the first row, we have A11, A12, A13. Let's obtain the values. So now the next is for A11, A12, A13, some will be positive, some will be negative, like we were doing before, plus, minus, plus, right? But we don't want to stress ourselves with that. How do you get to know the one that will be positive and then the one that will be negative using the conventional method or trickish method, which is very easy. Now look at it. For me to be able to know the one that will be positive, I need to add the number of rows to column. If the sum of the row and column gives me even number, it shows that it will be positive. But if the sum of the rows and the column gives me an odd number, it shows that it's going to be negative. What are even numbers? Even numbers are numbers divisible by 2 without remainder. Clear? So, if I add 1 plus 1, it will give me 2. Can 2 not divide 2? Yes. Plus. This guy becomes plus. If I add 1 to 2, what will I have? I have 3. Is 3 an even number? No, an odd number. This guy will be negative. If I add 1 to 3, I will have 4. 4 is divisible by 2. That's even number. This is plus. I hope you have understand how we get the sign. So the same thing we are going to do as we progress. So what will we do here? The first thing we want to do here now is to find the elements. Okay? That will be inside this matrix. So if we come to this original matrix, if I am here, I will cancel vertically and then cancel horizontally. We will be left with -1 and then 2, -1, 1. Then if I am here at this level, which is the second method, I cancel like this, then cancel like this, we have 2, 3, and then -1, 1. Then finally, let me help you. In order not to go back, after getting the first 2 matrices or first 2 elements, you can get the third from the first 2. The result you have for the first 2. How? The first, start from the second row. The first element here, the first column here, becomes the first column here, and the first column here becomes the last column here. It's as simple as that. Once you are able to get the first 2, the first one here becomes the first here, the first in the first element becomes the last in the last element. Another way to be sure if you are correct is that the starting column must be the closing column. I think I have passed a message. The starting column must be the closing column. So if what you have here differs from what you have here, you are wrong. Clear? Okay. Now let's look ahead. Then this becomes plus open bracket. Remember, we will need to introduce plus minus as usual, plus minus and then plus minus. -1 multiplied by this will give us -1, and then minus is plus. Plus 1 times this gives us plus 2. And then by the time we sum up, this will give us +1. We have gotten the new element for this. It's still 1. Let's see for that we still give us the same original elements that are there. Okay, then this is now equal to negative open bracket, which is this negative sign. A diagonal multiplication, this multiplied by this will give us positive 2, and then this minus minus is plus. 1 multiplied by 3 is plus 3, and then this will give us negative 5. 2 plus 3 is 5 times negative 1 is negative 5. Then for this guy we have plus into. Again, 2 multiplied by 2 will give us 4. And then minus minus will give us plus. And then plus 1 times 3 will give us plus 3. If we move further, this will have given us positive 7. So guys, we have been able to obtain the result for that. It's as simple as this. The next thing we're going to do here now, guys, is to what? Move down to the second row. In the second row, I have A21, which is equal to, if I add these guys together, 2 plus 1 will give me 3. Because it's an odd number, I will introduce minus. Okay? Then A22, this will give me plus, because if I add 2 to 2, it will give me 4, and 4 is an even number. Then we have this. Then by the time we move to A23, this will have given us minus. Why? If I add 2 to 3, that would have given us 5, and then 5 is an odd number. That's what we have negative. So let's fill in this matrix table. In order to fill in that matrix table, we are done with row 1. Remember that what we are dealing with now is row 2. So we'll come here. This is the element we want to find. So if we cancel like this, we have 2, 2. Can you see that? 2, 2, and then negative 3 and 1. So while you are on the second row, the only elements that will form your matrix will now be first and third. Remember, while we are in the first row, the elements that form all of these we are taken from row 2 and row 3. But now that we are using row 2 as our baseline, are you there, or as our reference numbers, therefore the element that will be present here will be from row 1 and then row 3. If this is clear, we are going to go. Okay, I'm super excited because I know you are gaining massive value. This is why we call this master builders. Okay, now we come again to this point. While I am here now, we are done with this. So while I'm here, if you cancel like this and again cancel like this, you have 1, 3, 1, 3. Then repeat what you had here before, minus 3, 1. Then I said that by the time you get the first two, to get the third is not a problem. The first element here will be the first element here, or the first column here will be the first column here, the first column here will be the last column here. Okay, and I did explain earlier that when the starting column is not the closing column, you are wrong. For you to be correct or to be accurate, the starting column must be the closing column. We are correct, right? Okay, so we introduce plus, minus, and plus, minus. Don't forget this. To solve this multiplied by this will give us negative, which is this negative sign, right? So this times this will give us 2, and then minus is plus, and 3 multiplied by 2 will give us 6. Everything here gives us negative 8. We are done with that element. Then when we come here, what next? The next option here now is that we need to also multiply this. 1 multiplied by 1 plus it will give us 1, and minus will give us plus 3, and 3 times 3 will give us 9. Yeah, plus 9. And then this is automatically 10. Then finally, when we come to this row, this multiplied by this will have given us positive 2, and then negative 2 multiplied by this will give us negative 6. And then the answer to this will have given us positive 4. Remember, 2 minus 6 will give us negative 4. And minus 4 times minus 1 will give us positive 4. Hope that is clear. Then guys, we are done with row 1, and then row 2. We need to get the elements in row 3. Then we begin with A31. Now A31, if we add these two guys together, sure we are going to have positive, because it's going to give us even numbers. So we have positive. Then if we have A32, this will give us negative. Why? The sum of 2 and 3 will actually give us, and then an even, is it even number? Will actually give us an odd number. And then finally, A33 would have given us plus. because if you add, okay, if you add 3 to 3, you're going to have 6. 6 is divisible by 2. Alright, let's fill in this gap. We'll come back to row 3. Now that we are in row 3, the only element that will fill up this space here will be from row 1 and then from row 2. Simple as that. Then if I am here, I will cancel like this, you have 2, negative 1, then negative 3, negative 1. I hope you can see it. Then if we are here, again now at A22, A32, if we are here, we cancel like this, we have 1, 2, and then negative 3, negative 1. And I said once we get to this level, the first element here becomes your first element here, and then the first element here will also become the first element here, 2 minus 1. It's as simple as this, guys. So in order to find the elements for this, or the values for this, again we introduce plus, minus, plus, minus, plus, minus. That's all. This is plus, open bracket. This multiplied by this will give us negative 2, and then minus minus will give us minus 3. And the answer to this is negative 5. While we are at this level, this multiplied by this would have given us negative 1, and then minus minus is plus 6. And the answer to this would have given us minus 6. Minus 5, right? That would have given us minus 5. Then finally, when we get to this last level, this will give us plus minus 1, minus 4. And then this will give us minus 5 again. So guys, we have been able to obtain the value of this matrix. It's as simple as this. So all we need to do now is to come back to our cofactor here. In place of A11, we put the value. In place of A12, put the value. In place of A13, put the value. Just like that, A33. It's as simple as this. So guys, you find out that to be able to solve inverse problems is something very easy. The only thing you just need to understand is our ability to be able to get the accurate values for each of these cofactor elements. Are you there? So now that we have been able to obtain this, we just come in here. Okay, now let's quickly route the board and then put in the value of all of these guys into this place. Once we do that, we are good to go. Okay guys, now the cofactor are C is equal to the first value is 1 minus 5, 7. Then the second value is minus 8, 10. Then we have 4. Then finally the last row is minus 5, minus 5, minus 5. I hope you can see this. These are the values we have as our cofactor. Now, in order to get the cofactor transpose, remember, for us to be able to find the inverse of this matrix, this is the formula. So we need to find our adjoint, which is same thing as transpose of the cofactor. So guys, what do you do to get C transpose from the cofactor? It's very, very simple. All we just need to do is to switch the columns to row or switch the rows to column. So row 1 will become column 1. Row 2 will become column 2, and then row 3 will become column 3. This is your adjoint. So therefore, we have that adjoint of A, which is same thing as cofactor, is equivalent to. Now, this is the first row. So the first row will now become the first column, 1 minus 5, 7. You see now, the elements we have in horizontal direction, we have made them to appear in the vertical direction. So this is our row 1 that automatically turn to column 1. The same thing, I will come to row 2 and make it column 2. Then this is 10, then this is 4. We are done with that. Then we'll move down to row 3 and also swap this minus 5, minus 5, minus 5. Now this is the cofactor transpose, which is also known as the adjoint of A. Now that we have been able to get to this level where we are, the next thing we are simply going to do is to find the inverse of matrix A. Remember that that is what we have as our equation 2 like you can see here. Are you there? So we said that inverse of matrix A is equivalent to 1 over determinant multiplied by adjoint of A or the cofactor transpose, which we already obtained. All we just need to do is to say, therefore, the inverse of matrix A is, this is the formula, and then this is 1 over modulus multiplied by adjoint of A. And then remember that this determinant has already been obtained as negative 30, so which is equivalent to 1 over minus 30 into the adjoint of A, which is 1, negative 8, negative 5, negative 5, 10, minus 5, and then 7, 4, minus 5. This is it. Now, there is one thing I need to explain to you here to always put you on the right track. Now, look at it. When you obtain the C transpose from C, which is your cofactor, there is something that should be constant in the two results. First, this is your cofactor, and then this is the cofactor transpose. So the leading diagonal in both cases must be the same. Now, the leading diagonal here is what we have as this guy. As you can see, this is it. So for you to be sure that your transpose is actually correct, you must ensure that it does not change even from your cofactor transpose or your adjoint. So let's get it out. And now this is the leading diagonal again. So as you can see now, as long as the value that we have on this leading diagonal is the same as the one that you have here, you are correct. But peradventure, after rearranging or changing your columns to row or your rows to column, and then you find out that what you have in this leading diagonal differs from what you have there is a sign or an indication that something is wrong somewhere. So to be on a safer side, you must check out if the leading diagonal is the same. I hope I have passed a message. Remember, we are teaching principles here that will help you solve as many problems that you have encountered with, right? So if that is understood, so we have been able to get the inverse. Then if we move further, we can automatically say that this is minus 1 over 30 into 1 minus 8 minus 5 minus 5, 10, minus 5, and then 7, 4, minus 5. It's as simple as this. So this is the inverse of this matrix. Take for instance, you are dealing with matrix as a topic, and then you are asked to find the inverse of the matrix. Remember, this is not matrix in each wise, but we are only applying matrix to solve set of linear equation with 3 unknown. Are you there? Pairs of simultaneous equation with 3 unknown. This is what we are using matrix to solve. Take for instance, is matrix as a topic you are dealing with. When you are asked to find the inverse of matrix A, what we have done so far from this process to clean off through this path and then end at this level is the processes involved to find the inverse of a matrix. So if this question required us to find only the inverse of matrix A, this is the answer. But because we are using inverse of matrix A to find, or using inverse method to find set of linear equation, we will now take one more step. Now we will say, okay, to find x1, x2, and x3, which is the same thing as x, y, z, or a, b, c, 3 unknown, or alpha, beta, theta. Then what do? You simply recall that x is equal to inverse of matrix A multiplied by B. Remember, we defined this as our equation 1. Now we know B, given from the question as defined earlier. We've cleaned that part, which is the same thing as the constant that we have at the right-hand side of the given equation. Is that clear? Then we have been able to find A inverse. All we need to do is to find the product of inverse A and then B. That's all. So we now need to substitute for this guy and then substitute as well for B. Hope this is very, very simple. Guys, nothing is difficult here. Only that you need to understand principles and the basic steps. Now, let's wipe that other page of the board so that we can continue the solving process. Okay, now what we need to do now is to put in the value of x here, which is x1, x2, x3 as defined earlier on. So we'll have this as x1, x2, x3, all equal to 1 minus 1 over 30 into, remember, we are multiplying inverse of a by b. So this inverse of a, then we have 1, negative 8, then negative 5, negative 5, 10, negative 5 again. Then last but not the least, we have 7, 4, negative 5. All multiplied by, now we come here, we have 311 minus 5. 311 minus 5. This is what we call our B earlier on when we started. It's as simple as this. All we need to do now is to multiply this matrix. Remember that in matrix, for instance, multiplication is only possible when the number of elements in row here equals to the number of elements in column here. So as you can see now we have 1, 2, 3 elements in row, and then we have 1, 2, 3 elements in column. So as long as the elements in row in matrix 1 equals to elements in column in matrix 2, then possibility of multiplying these guys is on a high side. So we need to multiply. And in multiplying this, you introduce a horizontal line here and then introduce a vertical arrow. What does it mean? It means that we are to multiply 1 by 3. First multiply by first, middle multiply by middle, and then last multiply by last. Sum everything together to give you one value. Are you there? One value. So in order to have this done, this is equivalent to minus 1 all over 30 into 1 multiplied by 3 give us 3, minus 8 multiplied by 11, that will give us minus 88, and then minus 5 multiplied by minus 5 will give us plus 25. We have successfully used row 1 to multiply everything in this column, and then we have summed up the results together. Hope you get that clear. Now we move down to row 2. Row 2, the first element here, we multiply the first element here, and then this will give us minus 15, which is 3 multiplied by the 3 multiplied by negative 5, and then 10 multiplied by 11 will give us plus 110, and then minus 5 multiplied by minus 5 will also give us positive 25. I hope you can see this clearly. If this is clear, then we move ahead. While we are at this level, 3 multiplied by 7 will have given us 21, plus 4 multiplied by this guy will give us 44, and then minus 5 multiplied by this will give us plus 25. Again, as you can see, it's as simple as this. All we need to do now is to have this as minus 1 all over 30 into. If we sum up these two guys together, guys, we will have this as minus 60. And then, if we sum up the values that we have here, this will give us 120. And if we sum up the values that we have here, this will give us 90. It's as simple as this. But remember that this is x1, x2, and then x3. So in order for me to find x1, this coefficient at here will multiply the first element here to find the value of x1. Same for x2, multiply the middle. Same for x3, multiply the last. So therefore, x1 is equal to minus 1 all over 30 multiplied by minus 60. And if we do this, the answer to this will give us 60 all over 30, and this will give us 2 positive results. It's as simple as this. Then by the time we come to x2, x2 will have given us minus 1 over 30 multiplied by the middle number, which is 120, and this will give us minus 120 all over 30, and this will give us minus 4. Then finally, to find x3, x3 becomes minus 1 all over 30 multiplied by 90, and then this will give us minus 90 all over 30. Answer here becomes minus 3. So therefore, x1 is equal to 2, x2 is equal to minus 4, and x3 is equal to minus 3. These are the results for x1, x2, and x3. So guys, as you can see now, even while we use inverse matrix method, we also obtain the same result we obtained when we applied the matrix method or the determinant method. So you see that this is very, very simple. We have been able to obtain both results. Now that we have gotten this, the next option is to check this question out using the Gaussian elimination method. Hope you are excited already. Don't forget, when you understand principles, you become a principal. When you understand boundary conditions, you will not overstep your boundaries. It's as simple as ABC. Now, guys, one of the things you will need to do here now is to ensure you like this video if you have not done so. Ensure that you subscribe to this channel if you have not done so. Then turn on the post notification bell so that whenever we upload mind-blowing content, guys, even while you are asleep, you will be notified. Guys, without further ado, let's jump into the next phase of this question when we will be using Gaussian elimination. Alright guys, welcome back to another section. In this section, we shall be using the Gaussian elimination to unveil or to solve three unknown equations, three unknown parameters. Remember, in this content, we have used the matrix or determinant method. We have equally used the inverse method. Now we are about to use the Gaussian elimination method. Now, in using Gaussian elimination method to solve sets of simultaneous equations with three unknowns, what do I really need to do? What must I do? What is actually required of me? Simple as this. So the first thing you want to do here is to ensure that first is to convert these sets of given equation to its equivalent matrix form. You have to first of all rewrite this expression in its matrix form. That's how it is. As the name implies, Gaussian elimination. That means there are some certain unknowns that we need to eliminate in order to find another. But let's get into this business. Of course, on the board, the first thing we want to do is to write the equations in matrix form. So to write this set of equations in matrix form, of course, this is no longer new. All we just need to do is to have the first element, the coefficient of x here, and that of the x there, and then this is 3. We'll come to the second unknown. The coefficient of x1 have been taken out. The coefficient of x2 in both equations includes this guy, minus 1, and then 2. Then finally, for the third unknown, we have -3, -1, and then +1. All multiplied by the unknown, x1, x2, and then x3, equal to the constants that you have here. 11 and then -5. Remember, like I told you before, whichever method that you are using here, you must first of all convert or rewrite the sets of equations in its equivalent matrix form. Having done this, what next? The next thing we want to do with Gaussian elimination approach now is to write the argument of this equation. So the argument of this particular equation is given as you can see. So converting this set of matrix to its augment form or this argument form, we need to have this as 1, 2, 3. Then we have 2 minus 1, 2. Then we have -3 minus 1. Then 1. We create a boundary here, a very straight line. Then this argument is bringing this constant term at the right hand side to the left end in order to meet with this. So we use a dotted line this way to separate the left hand side from the right hand side. So in this case, this is 3, and then this is 11. This is -5. So what this argument equation helps us to do is to help us exclude the variables that are unknown, but knowing fully well they are actually here, but we have silenced their presence. Are we there? All we need to do here now, guys, is to start adopting the real Gaussian elimination. Now, let me hold you by the hand and show you the principles that will help you gain mastery when solving problems using Gaussian elimination. One of the things is, in another set of video, guys, I will show you again how to use the triangular decomposition to as well solve these three sets of linear equations. Yes, triangular decomposition. Now, in order to have this done, guys, what is the interest of Gaussian while using this approach? The interest of Gaussian, just like regular or the conventional method of solving simultaneous equation, we said we have substitution, then we have elimination. In using elimination, what do? You decide on the variable to find and then decide on the one to eliminate. So for instance, in our videos when I was teaching on second simultaneous equation with two unknown, if you have not watched those videos, you can check our content or our dashboard where you can see videos on simultaneous equation with two unknown using the conventional method, right? So I did explain that if I choose to eliminate x, that means I want to find y. And if I equally choose to eliminate y, that means I want to find x. So if you eliminate one, you find the other. And if you are finding the other, you must eliminate one of them. So in the same vein, in the interest of this guy, you don't decide on what to eliminate. The man has already given us the condition to the variables that we must eliminate. So now let me take you through it. Now remember that this is row 1. According to the theory of Gaussian, you have no business touching row 1. But when you come to row 2, what you do in row 2 is to eliminate the coefficient of x1. In other words, make x1 coefficient to be 0. Like you can see now in row 2, the coefficient, let me put it here so that it's very easy for you. This is row 1, this is row 2, and then this is row 3. As you can see on the board. Row 1, row 2, row 3. Column is not applied here, okay? We are only working with rows. So in row number 1, the first thing that you gotta do is to ensure that you keep all the coefficient constant. Then when you come to row 2, what you need to eliminate from row 2 is the coefficient of x1. That must be eliminated. That is the theorem. So in row 2, we must find a way to eliminate the coefficient of x1. Then by the time you come to row 2, this is for row 1. By the time you come to row 2, you need to eliminate the coefficient of x1 and that of x2. So that means from here, I need to make the coefficient of this guy 0 and then make this guy 0. So in a real sense, what Gaussian elimination purpose actually do is to ensure that all the elements at the lower case automatically become 0. Above the leading diagonal, we have the upper value, uppercase matrix, right? Then below the leading diagonal, we have the lower matrix. Take for instance, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is the leading diagonal. Okay? And then maybe this is matrix for instance. The elements 2, 3, and 6, they are the elements at the upper matrix, the uppercase matrix. Then these 4, 7, 8 are the lowercase element. So what Gaussian elimination is interested in is to have these values here at the lowercase tend to 0. So the question is, as I begin to solve this question, even with other problems to solve after this class, you must ensure that your interest is to make this guy 0, make this guy 0, and then make this other guy 0. So you'll find out that there is no one way to solve this problem. In order to be able to make this guy 0 as we have it here, it depends on the parameters that you are given and your interest. Yes, you heard me right. So in this case now, if I want to eliminate 2 here, I will do a theory that will help me, or I will propose an equation that will help me eliminate this. The same way, if you want to eliminate this or this, I will also propose a model, an equation that will help me eliminate this. So how do we get to eliminate this? Like I mentioned now, we'll find a way to make this 0, and then make this 0. In order to have this done, you will now follow me as I hold you by the hand and walk you through again how to have this job done. I've just given you the description of the interest and what you need to do. So I want to show you how to do it. I hope you love that. Okay. Okay, so guys, now we have successfully gone through the analytical description of how Gaussian elimination works. Now let's apply it. Okay, like I did mention before, the first thing you want to do is to ensure you keep row 1 and then find a way to eliminate this value, make this 2 0, and then find a way to make this 3 0. So the thing is, what must I do to equation 1 such that if I remove it from row 2, I'll be able to get this guy to be 0. Alright, let me assume I leave a space here to fill later. Then let me start from here. This is 1, 2, minus 3. Then we have our boundary. This is what we have. Alright, so this is the first element. Nothing will happen to this. So what must I do to make these guys 0? What must I do? If the interest is to make this guy 0, what must I do to make this guy 0? In row 2. So the thing that you need to do is find a number so that if you multiply it by 1, the element in row 1, and then remove it from this guy, it will give you 0. What must I multiply by 1? Such that if I remove it from 2, it will give me 0. Is 2 times 1. So 2 multiplied by 1 minus 2 will give you 0. Is that correct? So you will simply come here and say subtract 2 times row 1 from row 2, and again. Now remember, for me to be able to eliminate this guy, I need to multiply this guy by 2 and then remove it from this to make it 0. The same way, if I want to eliminate x1 here, remember the first. So all we need to do now is to what? Ensure that we make the coefficient of x1 in row 2 and row 3 0. And that's exactly what we are doing here. So to make that of row 2 0, we have already gotten a relationship. Now, how do we also make that of x1 in row 3 0? All we need to, guys, is to ensure that we multiply this by 3, so that when we remove that 3 from this 3, it will give us 0. So we also say that and subtract 3 times row 1 from row 3. So by mathematical induction, what we mean now is that this row 2 will be row 2 minus 2 row 1. Why for row 3 to get the relationship, this becomes row 3 minus 3 row 1. This is how we are going to get this value. Row 2 minus 2 times row 1. That's this statement. Subtract 2 times row 1 from, you get it? 2 times row 1 from. That means when you multiply row 1 by 2, whatever result you have, remove it from row 2. The same thing, whatever you have, when you multiply row 1 by 3, whatever you have, remove it from row 3. So we're able to come up with this relationship. Now follow me as we now get new values that will now take row 2. In order to get the values that will occupy this row, remember the first element here now in row 2, remember we are using this arrow 2 minus 2 arrow 1. This is what we are using, our relationship. Like I said earlier, you need to generate an equation that will help you get the new elements here, which we have got it. Subtracting 2 times row 1 from row 2. So this is the model. So the first element I want to replace is 2 minus 2 times. What is the element in that same column in row 1? That's 1. And then this would have given us 2 minus 2, and this is 0. So put that value here, that's 0. We have successfully eliminated the coefficient of x1 in row 2. Are you there? Then we will move to this. In order to find this again, the value of row 2 there, using this model, is minus 1, then minus 2 times. What is the value of row 1 corresponding to this same column is 2. So if I am dealing with column 1, I will keep the value in row 1 there. Now that I am dealing with column 2, I also keep the value in row 1. That's why we have these two in brackets. Automatically, this is minus 1 minus 4. Everything becomes minus 5. So this is now the new value that we have here. Then again, still using this equation, in order to find the value that is here, what value is initially there? Minus 1. Put down that minus 1. Then minus 2 times, we are still using this equation. What is the corresponding value of row 1 on that column? Minus 3. So put down minus 3. And then this will give us minus 1 plus 6. And this will give us plus 5. We put down 5 at this here. I hope you are following me. Then in order to get the last one for 11, remember I want to replace this again. Put down 11. Still using the same formula. 11 from row 2 minus 2 times the equivalent value in that same column on row 1. Then the value is 3. This will give us 11 minus 6, and this will give us positive 5. So we have this as 5. It's as simple as this. As simple as this. Okay, I hope you have gotten how we have obtained the values for row 2. Now let's quickly get the values for row 3. In order to get value from row 3, we also said let 3 times row 1 be taken away from row 3. Which is this model? Subtract 3 times row 1 from row 3. This is the relationship. So if I want to change the value here, I'll first of all put the value here down. So the first value we have in row 3 is 3 minus 3 times the equivalent value of row 1 in this column is 1. And then this will give us 3 minus 3, we have 0. And that's our interest. We have successfully eliminated the coefficient of x1 in row 2 and then in row 3. So now we want to get the new value in this position. How do we get this? The correct value there is 2 minus 3 times row 1. So the equivalent value in row 1 there is 2. And then we have 2 minus 6, and this will give us minus 4. We have this guy here as minus 4. It's as simple as this. Then the next thing we're gonna do is to come to this element. We want to replace this one here. Then we put down 1 minus 3 times the equivalent element you have in row 1 on that column. And then this is minus 3. This will give us 1 plus 9, and this is 10. So put down 10 here. It's as simple as this. Simple as this. Then the final thing we will quickly do, guys, is to find the value that will be here. We initially have negative 5 there, so put that at negative 5 minus 3 times the equivalent value of row 1 on that column, and that's 3, positive 3. Then this will give us minus 5 minus 9. I hope you can see it there. Minus 5 minus 9, and then this will give us minus 14. This is now negative 14. We have successfully eliminated the coefficient of x1 in both row 2 and row 3. Remember, if this is the leading diagonal, alright, we still have negative 4 left to be eliminated. Remember, in row 2, our interest is just to eliminate the coefficient of x1. But in row 3, our interest is to eliminate the coefficient of x1 and that of x2, leaving only x3 behind. So if you understand this concept, so what must we do now to bring down this guy to 0? That will now be the interest. I hope you are following me. Principles are what makes you principal. What must I do to this number to convert it or bring it down to 0? Then you now begin to think, what must I multiply by what? So, having known that we are to eliminate or convert this value to 0, all we simply need to do now is to make row 1 and row 2 constant, because we don't have any business with it again. The requirement is that all the coefficients here must remain the same, and the requirement is met. The requirement here is only the coefficient of x1 should be made 0, and the requirement is met. But when we come to row 3, all we just need to do now is that the requirement is not fully met, because the coefficient of x2 in row 3 is still existing. So what must we do to make this guy 0? Can you follow me? Follow me. So in order to do this again, we will still put down somewhere subtract. Now there are so many ways to do this. You can decide to divide this all through since 5 is common, but that will not be the best option. Let's leave that aside. So what we'll now do is that subtract whatever, subtract A times row 2 from row 3. So we'll now be looking for what we will use to multiply row 2 so that if we remove it from row 3, this guy will be 0. This particular one. Every other thing is not your interest, but this one. So it means that for us to be able to deduce an equation that will help us reduce this guy to 0, which is this negative 4, we must ensure that we do that relationship between row 3 and row 2. We no longer have business with row 1. No business with row 1. But now, how do I get this A? Remember, it's not A here. There is a value that needs to be here, just like we have 2 times row 1. Just like we have 3 times row 1. What must we multiply by row 2? Such that if we remove it from row 3, we'll be able to make this guy 0. You capture the revelation? It's as simple as that, guys. When you know principles, you become a principal. When you understand boundary conditions, oh guys, you will not overstep your boundaries. We are actually applying principles. We love principles because principles makes us principals. Are you there? Now we push. I need to find what will be here. Remember, it's not A that will be there, but let me find what will be there. How do I get the value? Now, the question is, what must I multiply by this 5? Remember, for me to eliminate this, I will need to consider the element in that same column in row 2. In that same column, so this is column 2. The element I want to eliminate in row 3 is in column 2. So whatever I have to do with this now must be on this row. Whatever I need to multiply by anything to make this guy 0 must be taken from this same column where the number I want to eliminate or convert to 0 lies. So now the question is, what must I multiply by this guy so that if I remove it from this, it will give me 0? This is where the problem comes. So that means I need to have row 3 multiplied by minus something multiplied by row 2. What will be here? What will now be in this bracket? That's what we are looking at. The same thing we had before. Row 3 minus something times row 2. What is that thing? So because of the fact that we want to eliminate this and then we do not have an exact value that we can use to multiply this, or like 3 multiplied by 1, we're able to put this guy down. There is none. And we don't use decimal values here. We can use fraction or whole numbers, not decimals. So what do I do here? Now follow me so that I will show you. In order to be able to eliminate this, all I just need to do is the elements I want to eliminate. What element do I want to eliminate? I want to eliminate this. I will now say 4 all over the number I want to eliminate it. I want to multiply it. This is minus 4. This is minus 5. Minus minus, we cancel that. I hope you understand this. As simple as this. So what we need to do now is to say row 3 minus 4 over 5 times row 2. So that if I put 5 here from row 2, this cancels, I'm able to get it clear. It's as simple as that. Simple as that. Hope you understand what I've just explained. It's simple as that. So now, since we cannot get an exact value, just look at it. Since you cannot get an exact value, a singular value or number that when you multiply it by 5 and then remove it from 4, it will give you 0, just get the fraction of the two numbers. The one you want to eliminate becomes your numerator. The one you want to multiply it with before removing from it becomes your denominator. So this is the one we want to eliminate, serve as numerator. The one we want to multiply it with becomes our denominator. So like I just mentioned now, if you put in minus 5 minus 4 here, minus cancel minus will reduce this to positive value. So we are quickly going to say now that subtract 4 over 5 times row 2 from row 1. I hope you understand how this 5 over 4 over 5 comes in now. All we just need to do is to create a column again. These are matrices. Remember 1, 2, minus 3, then 3. Again we have 0, minus 5, 5, 5. And then finally, this is it. Like I mentioned, nothing will happen to row 1, nothing will happen to row 2. They now remain constant. So now, how do I now find this? In row 3 now, our model becomes something like this. To find row 3, we have arrow 3 minus 4 over 5 arrow 2. Now let's work this out here. We have arrow 3 minus 4 over 5 arrow 2. So now the first value in row 3 is 0. And the value in row 2 is also 0. So this is 0 minus 4 over 5 times 0. Everything will give us 0. So we still have this guy back as 0. Then we move to this. This is our actual point of emphasis, right? Now this number here in row 3 is minus 4. So you put down minus 4. Then minus 4 over 5 multiplied by, what's the value in that same column in row 2? Minus 5. Put here minus 5. This multiplied by this cancel out. Then you have minus 4. Minus times minus will give us plus 4. Automatically we have this as 0. Oh, guys, we have successfully achieved this. Now, finally, we move down to this and then this. So I want to replace this. This becomes 10 minus 4 over 5 multiplied by the equivalent value in row 2 on that column, and that's 5. Then this cancel this, we have 10 minus 4, and the answer to this is 6. So here we have 6. Then finally, I want to replace 14. I have this as minus 14 minus 4 over 5 multiplied by 5 again. Because we have 5 on row 2 there in that same column. And then this will have given us 5 cancel 5, we have minus 14 minus 4. Minus 14 minus 4 will give us minus 18. Then we have here as minus 18. Now guys, now that we have been able to get to this level, we have fulfilled the theorem of Gaussian elimination that says we should successfully convert all the elements in the lower case to 0. So all the lower elements have become 0. Remember that this is our leading diagonal, as you can see here. This is the leading diagonal. Okay, so we have successfully converted all the elements at the lower case to be 0. If this is clear, we are good to go. All we now need to do now is to bring this guy back to this original equation. How do we convert this back? All we need to do now is to have this as. And this is what we normally call backward substitution. Backward substitution. Alright, so in this case, we now have 1, 0, 0 multiplied by 2 minus 5, 0 minus 3, 5, 6 all multiplied by x1, x2, x3 all equal to the new values here becomes 3. Remember that this is what separates the left hand side from the right hand side. Are you there? So this is 5, then minus 18. Now using backward substitution, in using backward substitution, the interest is to start from the last row. Remember, in the last row, we only have the coefficient of x3 existing, just like we have it. So what you just need to do as usual, converting this back to its equivalent equation. Remember, we were once given an equation that we converted to matrix. Now at this level, we need to convert this matrix back to the equation, having succeeded in eliminating this guy, and this guy. So we start from row 3. Now say from row 3, what do we have here? 0 times x1 is 0, plus 0 times x2 is 0, plus 6 times x3. We have 6, x3 is equal to minus 18. Because I'm looking for x3, I will simply make x3 the subject of formula. And if we do that, x3 will give us minus 18 over 6, and the answer is minus 3. Are you beginning to enjoy this? We have minus 3 when we use other methods earlier, right? But in this case, we start from behind. Now, in order to do this, the next is what? From row 2. In row 2 now, we have x2 and x3. So when we also do our multiplication, 0 multiplied by x1 is 0, minus 5 multiplied by x2 is minus 5x2 and then plus 5x3 is equal to 5. This is what we have. And now, what is the value of x3? This becomes minus 5x2 plus 5 minus 3 is equal to 5. And then minus 5x2 is equal to 5 plus 15. Remember, plus 5 multiplied by negative 3 will give us minus 15. As we take it across the side, we have plus 15. And automatically, when we add this guy together, we will have it as 20. And we'll be dividing both sides by. And then we'll be dividing both sides by negative 5. X2 is equal to 20 divided by minus 5. And this will give us negative 4. Is this wonderful? Are you enjoying this class already? Finally, from row 1, we now need to find x1. Remember, we call this backward substitution. So we have found x2 and x3. We need to find x1 from row 1. This is why we always keep this constant. Row 1 is the same thing as the given equation 1, as you can see here. So if you don't want to stress yourself, just come back to the given equation 1, and then put in the value. You are good to go. So when we come back to row 1, this multiplied by this. So we are here. This multiplied by this gives us x1. Then this multiplied by this gives us plus 2x2. And then minus 3x3 all equal to 3. As you can see there. So it's exactly the same thing as row 1. All we just need to do now, guys, is to put in their values. X1 is plus 2 times x2, as you can see, is minus 4 minus 3 into the value for this other guy again is minus 3 equal to 3. So x1 minus 8 plus 9 is equal to 3. Minus 8 plus 9 would have given us plus 1. So we have x1 is equal to 3 minus 1. Therefore, x1 is equal to 2. That's it. Hence, guys, our final answer becomes x1 is equal to 2, x2 is equal to minus 4, then x3 is equal to minus 3. These are the answer to this set of equation using the Gaussian elimination method. So guys, as you can see already, you find out that using the matrix or determinant method, using the inverse matrix method, or using the Gaussian elimination method, you will always have the same result. The same result is applicable all through. Alright, so guys, I haven't taken you through to this level, and as I promised to teach you how to use Gaussian elimination, how to use inverse matrix method, and how to use matrix or determinant method to solve simultaneous equations with 3 unknown, I've actually fulfilled my promise. If you actually gain value from this channel, or you stay tuned watching from the first method through the second to the third method, and you have stayed on this channel watching this content, I guess that this content has actually added a value to your life. So in order to encourage us, just subscribe to our channel if you have not done so. Do well to help us share this content, share this video, like this video, and don't forget to leave a comment below. If you have any question, drop it below. If you want to appreciate us, drop it below. Anything that you have in mind to say about this lesson, put it at the comment section below. We love you guys. Thank you very much. Thank you for watching. In our next module on this aspect of simultaneous equation with 3 unknown, I will be teaching you again how to use Gaussian method and how to use the triangular decomposition method. I will see you in that video. If you don't want to miss it up, please subscribe, turn on the post notification bell for more updates. Love you guys. Thank you, thank you, thank you, thank you, thank you. See you guys in the next class.